So you're getting close. So here, what we're going to have is this is called summation notation. This is still in 7.1. Summation notation. Yeah, what's up?
I just want to know if you can record the Zoom. She's not home right now.
No problem. I set it up to record. Hopefully, I know my 10th period class, theirs got corrupted. Hopefully this doesn't get corrupted, but I'll post it right after. Okay, so this is summation notation. Okay. This whole thing would be called summation notation. Summation notation. The thing on the bottom would be our lower bound. You could also refer it as your starting point. If the bottom is the lower bound, the top should be the upper bound, or also known as the final point.
What's that, 6?
That's 6, yeah. That's the number. These are always going to be numbers. So n equals 1 on the bottom, 6 on top.
Okay.
So the question is, what does this weird symbol even say? What this weird thing is saying, add all the values of 2n plus 1 between steps, I should say, steps 1 to 6. So I'll try to underline and color a little bit what each part is showing you that. So this weird E shape represents adding all values. It's also called the summation notation, or a sum. So this E part right here tells you I'm going to add the values. The actual equation, or how you get your values, is going to be inside the summation. So it's going to be inside here, 2n plus 1. And where you start and go is going to be based off the bottom and the top. Okay. So let's actually do it. So before we could add all the pieces together, we just have to find all the pieces. So I need to figure out, and this is from yesterday's lesson, A of 1, because I'm starting at 1, A of 2, A of 3, A of 4, A of 5, and A of 6. I find each piece because I'm going to add them all up at the end. So when I have A of 1, that means every n value, every n in the equation turns into a 1. So 2 times 1 plus 1, that's 2 plus 1, or 3.
Isn't this what we did last time?
We did this last time. What's new is this part here, which is forcing us to add it. And then we're going to see there's shortcuts to adding it eventually. But first, we're just practicing what does it mean and what is it telling me? But finding the points, it's still the same. I plug in 2. I plug in 3. I plug in 4, 5, and 6. After a while, you might see the pattern and you could go a little faster. Well, it seems like I'm adding 2 each time. So 9, 11, 13. And after you find all your pieces, all we're asking is to add them all together. So 3 plus 5, hold up, plus 7, plus 9, plus 11, plus 13. You add that all together. I see a 20, a 40, a 48. So you add that all together, you should get 48. What's up? Was it Mariah? Go ahead.
How did you get the 7? Because I thought 2 times 3 is 6 plus 1, which will give you.
2
Wait.
times 3 is 6 plus 1 is 7. Yeah.
Never mind. I repeated something. Never mind. I saw what I did. Never mind. I got it.
No problem. No problem. Yeah. So the final result is 48, basically. Pretty straightforward. Find the pieces, add the pieces. What's unique is just the new way I say it with this particular notation. So everyone, while you finish writing that, I'll give you one that I would like you to try yourself. So n starting at 1, let's say to 5. Let's do n squared. Okay. All right. So everyone try that out. And you could probably send me the answer for you if you want me to check. Nah, good with the numbers? Then you just have to add them all together. What you're doing, Mariah, 5 and N1 tells you where you start. So I start at A1 and where I go to. In this case, is A5. So it tells me where I start and where I finish. You must have added an extra 1 now, I think. You're just 1 off. Unless I'm doing my math wrong. Let me just check. 20, 30, 40, 50. Yeah. Just check your adding. You might have added 1 again or something like that. Eliana Nahum Sheva, good job. Haley, good job. So you plug it into that equation, n squared, and your values, Mariah, good job, should be 1, 4, 9, 16, and 25. You add that all together, you should get 55. Good job on everyone. No problem, Mariah. Okay. All right. So that's the basis of sum notation. Now, the ones we've been doing always started at 1. That's not necessarily always going to happen. So let's do one like that. Should be better looking, but whatever. Let's do 4 through 7. What's a good one? 3n. So write down that problem, and then we'll talk about it.
Mr. Tobal, Carmela's Zoom logged her out, so she's trying to get back on right now.
All right, I'll keep an eye out when she tries to get back on. If not, again, I record this just in case.
Is that for from the 4th position?
Yes, good. So instead of starting at the first position, which we are used to doing, and normal sequences you do every time, what you start is at the 4th position. So instead of A1, you're going to follow what the bottom term here, which is 4, and you're going to start A4, which means you go to A5, A6, and you keep going up until you get to the final position, which is based
Wait,
off this.
Mr. Toro, you don't start at A7?
No, you start at the bottom and work your way up.
Oh, my
Or
bad,
the
my
7.
bad.
Which also showed you that the number on the bottom should always be smaller. If it's bigger, then there must be an error. Whether I made a mistake or something's weird. Okay. So instead of doing 1, I'm going to plug in 4. And the concept is still the same. You're just using different numbers. 3 times 4 is 12. 3 times 5, 15. 3 times 6, 18. You might see the pattern, but if you don't, you could always just plug it in. 3 times 7, 21. Then our job is just to add it up. 12 plus 15 plus 18 plus 21. 30, 45, 50, 66. This should be 66. 66, yeah. Hopefully nothing too crazy on that one. Just you gotta start where it tells you to start, which should make sense. Find this one. Yeah, there we go. Okay. Let's go up a notch. Let's zoom in a little bit. Chat. Yeah, 66. Let's do another one. This time we're going to make it a little bit more interesting. Let's do 1 through 15. 2. I should say n equals 1. It should be whatever variable. So n equals 1, I equals 1. We'll see different variables on the homework. K equals 1.
Mr. Toro,
Yeah, Mariah.
so we start at 1, like A1, and then you like continue from there all the way to 15. But you
Yeah.
figure out the pattern after like about 4 times.
Yes. Now, but here's the interesting about this. The equation here is just 2, which means, Eliana, A1, what is my A1? What is that going to equal?
2.
Good. Nahim, what is my A2 going to equal?
A2 is going to be 4.
No, there's no N there. So it's just going to be
So it's just 2.
just 2. Sheva, A3. What is
Wait, is that the trick the whole time, Mr. Torvald? That it's just 2?
So
there's
it's
no
all
N?
2 because there's no N in the thing.
exactly both of you guys? Good. The trick is there's no N. So because there's no N, it doesn't matter if I plug in 1 or a billion. It doesn't change the value. A4 is 2. A5 is 2. Now, if I said from 1 through 15, that could be really annoying to actually write 2, 2, 2, 2, 2, 2, 2, 2, 2 multiple times. But we learned something back in elementary school, how to add something repeatedly over and over again. Does anyone know how you add the same thing over and over again?
Multiply.
Thank you, Sheva. We multiply. So instead of doing 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, we're just going to do what's the distance between 1 and 15? I shouldn't say what's the distance. I should say,
Wait, why are we multiplying?
I'll tell you after. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 15 numbers. So we have 15 twos. So 15 times 2 should be 30. So you could just multiply. It's not necessarily the difference. So you don't want to do 15 minus 1 because you got to count 1 itself. So you could do like the difference plus 1 if you want to do it like that. But it's safest as always just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So you have 15 ends. Now, Mariah asked, why are we multiplying 15 times 2? Well, Mariah, you could technically write 2 plus 2 plus 2 plus 2 plus 2 plus 2, ...
You're saying that equals 30, all those numbers together?
Yes, because
You
multiplication
just take
is
the top times the middle. You take the top times the middle number when there's no next to the end to it, and that's how you figure out the final answer number.
let me give it another example because it's not always just the top. So I'll give it another
Got it.
example. So n equals 5. And let's do 11. And we'll put a 3 here. Okay. So what would technically happen if it was something like 3n, but it's just 3? Well, you would do a of 5, a of 6, a of 7, a of 8, a of 9, a of 10, and a of 11. So you would do 7 A's. You would do 7 A's. But because this is just 3, all your A's are just 3. Three added to itself 7 times is 7 times 3, which is 21. How you figure that out? You can simply do the top. So I'll put that here. Top minus bottom. You're going to have to add 1 at the end. So 11 minus 5 plus 1 gives you 7. The reason you have to add 1 at the end is because you got to count 5 itself. You got to count your first step, which normally when you subtract, you don't count. So you just do a plus 1 at that.
How
If
do you know when to do that, Mr. Torvald?
When you have only a number on the inside. So no n or variable, which means it doesn't change. It's always 3. Okay. So that's how you know, because it's just a constant number. Let's see. Is there any other special versions I need to talk about? Constants. I don't really care about that one. I'm just doing a real quick check. Hmm. Let's see. Yeah, no, nothing special really. No problem, Ryan. So I'll just give you your exit ticket and then post the homework. It will be, let's do G equals 5 to 9. Let's do N over 3. Yeah, that's cool. All right. This will be your exit ticket. If it's a fraction that could be simplified, try to simplify the fraction. Find the sum or solve this equation, this notation. You could leave it as an improper fraction. Doesn't simplify to a whole number. Remember, when adding fractions, you just need them to be a common denominator. Lucky for us, they should always have a common denominator because nothing really changes. N over 3, yeah. Haley, first one in, first one out. Have a wonderful day, Haley, okay?
Thank you.
No problem. Guys, keep trying it. Eliana, a little short. Don't simplify the numbers before you add. Just leave them all fractions and then add them. Because it's easier to add all of them as a fraction first. Ella, you're good to go. Have a wonderful day.
Thank you so much.
Mhm. Sheva, you're good to go. Have a wonderful day. Whoa, why did I have $2,000 here? Oh, yeah.
Can we leave after we copy it down?
Yeah, just type in the answer correctly so I know you finished looking at it. Even though I know the answer's there, but just for my attendance later.
Sorry for doing it. Sorry for not doing the equation because something came up on my computer. It's